PowerPoint-like template, but what it does is it exposes all the inside. So we'll do that. We're gonna make a little presentation in just a sec. And then, this is the presentation that gets made from this detail view. What it does is it takes that little snapshot, thumbnail of what I was doing, it takes the description I wrote and it makes a little slide. But let's just do it. So what I'm going to do is I'm going to come back and I'm going to fire up a fresh instance of Turtle Art, and we're going to make a presentation. So let's, first of all, go to our journal, and let's come to here. We were in the memorize activity. Remember that? So we had just made, a memory game based on the things you eat in a Japanese restaurant. Did I spell that right? Well, sushi bar. Okay, easier to spell sushi. Okay, so now let's go back to Turtle Art here, and we'll come to the portfolio page, and we're going to make a little presentation. So we grab this, and I click on here, and I grab that, and then I type here, sushi for lunch, and I just stick that over here, and lo and behold, we have the little presentation right from our journal. It wasn't too hard. But we can get a little bit fancier with this. We can make slideshows, and we can do things like make our slides change whenever we act. Yeah, why not? Let's do it. Let's be really anal here and crazy. All right, first of all I'm going to do, I just decided that instead of having the text on the right and the picture on the left, I want it different. So what we'll do is we'll just swap this. So now the picture is going to be on the right and the text is going to be on the left. So the kids can reprogram their presentations. But again, the idea of just sort of exposing them, presentations aren't a black box anymore either. Everything's there and available. And I'm going to show you that in even more detail. We'll do more Turtle Art presentation stuff maybe later. And again, it's prompting me to write in my lab notebook about what I'm doing. So what am I doing? This is my my sushi talk for Posscon. Okay. I'm just going to make a note to remind myself that Posscon has nothing to do with pest control. Okay. So I just remember that. So. Let's go back to Turtle Art and back to my talk and look at making mistakes. Well, you've seen me make lots of mistakes already because that's my nature. I like to make reference to the automotive industry. Some of you look like you might be my age, so you remember back when they used to make cars, big heavy cars out of steel. And it was great because you could take your car and you could hit anything. You hit a tree and nothing happens to the car, because it's just a big, rigid steel object. But the problem is that energy had to go somewhere. Where'd that energy go? Well, it went into the tree and it went into the driver. Not a good thing. So it took about 50 years, but the auto industry finally woke up to the fact that people are more important than cars. So they invented this concept called the crumple zone. So that instead of cars being heavy made out of steel, cars are light, and they have this zone that will crush and absorb the energy of a collision. So cars, maybe they aren't as fun as they used to be, but they're a lot safer. Now, what we try to do in sugar is provide the kids a crumple zone. And it's not because we are afraid they're going to get hurt, but it's because we want to encourage them to take risks. And the problem is that in most environments, when you make a mistake, it's bad. And you very quickly learn not to take risks because risks are what lead to mistakes. We want to encourage the kids to take intellectual risks because if you're not making mistakes in school, school is exactly where you should be free to make mistakes. And so we try to build into Sugar a lot of room for experimenting and breaking things. And we do that through a number of different utilities. One thing we do is we give the kids lots of different types of environments to play around in. We have this concept, I sort of refer to it as sort of a no ceiling idea, where you have a very low floor. It's easy in, and you can climb as high as you want. There's no upper bound to what you can do. We do that across all different domains. So we do it in music. In music, we have a program, Tam Tam, which I might as well fire some of these things up too, since I've got time. Where's Tam Tam? Here's Tam Tam. So Tam Tam is just it's really simple. I don't have, no, maybe I can get it to. It's sounding a little funky, but you have these different instruments and you hit the keyboard and you're making music. Really simple. Literally a 2-year-old can use this with no instruction. But it's still, it's a fairly low ceiling because you only have one voice at a time. You can turn on a drum as background, but you're basically single voice at a time. And you're restricted to the 100 or so instruments that we provide you. Well, they go from Tam Tam to Tam Tam Edit, which gives you multiple voices, and you're synchronized over the net with other kids and other instruments. And the kids in Thailand use this to make a village orchestra. And they also integrated with their parents all the traditional instruments, and they made some really cool music. They also invented their own musical transcription system so that everybody could share the same music. From there, you go to Tam Tam Edit. Lets you write music. And then from there, you go to the synthesizer lab because, as I said, we only have 100 instruments or so in Tam Tam, but maybe you want to design your own instrument. So here you get to design your own instruments. And then actually, you can go further than that because in Turtle Art, we have this concept called view source. And again, one mouse click away, one button click, and you get the source code of every program you're running. So the kids who are really get into music can go and start mucking around and discover this programming language called C-Sound. C-Sound is what the professionals use. So if you're in Hollywood doing music, you're using C-Sound. So we go inside of Sugar, we give you something that literally a 2-year-old can use without instruction, and a path to the same tools the pros use. So there's no upper limit. But at the same time, let me go back to this theme of crumple zones, because we don't want you to feel like you're going to break anything. So we use a number of different concepts. The most basic concept is just this idea of copy on write. Okay, so if you copy on write, then if you break your copy, it doesn't matter. But the other thing is that, since Sugar was designed for this thing, Sugar fits on one of these. And this is a 2 gig stick, which is more than you need for Sugar. So to just start over again, to reflash is pretty trivial as well. There's very little to break. But then we also sort of encourage you. So this is the same programming environment, Turtle Art, that I was using for my presentation. It's just sort of an easy entree into getting kids programming. This is a fairly complicated program, but there's nothing to break. This is a paint program. That's all you need to write paint inside of Sugar. That's a paint program. This is a video broadcast program. You turn on sharing, this just displays whatever the camera sees, so whatever the camera sees gets broadcast over the net, you've got a video broadcaster. That's not too complicated. But anyway, the idea that you let the kids get out there and do things and explore things and try things, and there are no black boxes. Here's another example. I'll just show you the real thing. So I was visiting my mother, try to get rid of some of this. I was visiting my mother maybe about a year ago now, and I found this book I had as a kid on how to use an abacus. And I said, hey, this is kind of cool, it brings me back. So I said, oh, well, so I wrote an abacus program for sugar. And this is the abacus program, and this is the Chinese abacus, and so this column is ones, tens, hundreds, and then above the bar it's times 5, so 5, 50, 500. And that's what it is. So if I wanted to, so that's how you use the abacus. But, and it turns out the Chinese weren't the only ones who invented this. The Romans invented it too. The Romans invented exactly the same abacus as the Chinese did. But there are others. So in Japan, they invented this abacus. Looks almost the same as the other one you saw, but you'll notice there's only one bead on top and 4 beads on the bottom. So you have to do the carry in your head and move it over. The Mayans had their own abacus as well. The Mayans had arithmetic that was base 20, not base 10. So they had 20 worth of beads here, and these beads are worth 20s instead of 10s, and then 400s and on like that. So I decided, well, since I'm the computer geek, we'll give them a hexadecimal calculator, hexadecimal, and why not go all the way and give them a binary abacus? So here's a binary abacus. But then, why stop there? Why am I want the kids to see that there are many different representations of the same idea in the world, but I also want them to be able to explore their own representation. So we built into the tool, because it's sugar, you can make your own. So let's make an octal abacus. So we'll make I don't know, well, since it's an octal abacus, we'll make 8 rods, 1 on the top, and maybe, so we want